Okay, let's try week 3 of distance learning. So, in this week, we're going to continue our statistics and we're going to talk about the 6-foot sign because that's actually geometry math. That's kind of cool. 2, we're going to review our statistics. So, we're going to talk about measures of center, measures of spread, and graphical data. We're going to talk about all of this as one variable data. So I'll talk about that in a few minutes. And then the assignment is actually going to be a lab where you're going to be doing some stuff, but that's online as well. So let's talk about the 6-foot. Second thing, office hours. The school is moving towards having specific courses have specific office hours. So math, that's me, geometry, has been designated as Thursday afternoons for office hours. So if you notice, I've expanded our office hours from 1 p.m. to 3 p.m. on Thursdays instead of just 2 p.m. to 3 p.m. So those are going to be my official office hours. Now, I don't want to compete with your other classes and office hours that you might need for your other classes. So it's really, really important that you hear me that these other office hours, the normal ones that I was having on Tuesday, Wednesday, and Friday, these are all optional. Actually, all of my office hours are optional. But I will tell you now, I will be online during these additional 4 hours in case you want to get online and you want some extra help. So that's Tuesday from 10 to 11 like normal, Wednesday 10 to 11 and 2 to 3, and then Friday 10 to 11 and 2 to 3. Again, these are strictly optional. These are just if you want to pop on and say hello, or you have a really quick question, or you're doing your math at this point in time. But I know that Tuesday and Wednesday, they will have scheduled office hours for your other subjects as well. They will have specific days. So math's official office hours are on Thursday, but I'm not going to tell you guys that you can't find me for extra help. And if none of these office hours work for you and you need additional one-on-one help, please, please, please email me. We'll set up a time that just you and I can go online and look up some stuff. So, all right, let's get into some math. So this sign is a sign that I found on the internet, and it was interesting because it was a Twitter picture that came up, and obviously I follow a lot of math teachers on Twitter and things like that. So this math teacher put this sign up that they found, and I don't know where the sign came from. My guess is it's coming from obviously a different country. But they used feet instead of meters, so I thought that was interesting as well. So I'm not sure exactly where this sign's coming from. Let me just preface that. But let's say that this is a true sign. And I'm going to draw on these, are these two people actually meeting the guideline? Because you've heard the guideline, same as I has, that we should stay 6 feet apart from people. But are those two people 6 feet apart? Based on this picture. So if we base it on this picture, you guys can see very clearly that we've got a square, right? And we are told that person A and person B, are supposed to be how far apart? 6 feet. True? But is person C 6 feet apart from person A and person B? There's my question to you guys. So if you look at this picture and you go, hey, PK, wait. You, in one of our units, put this picture up. It might not have been 6 feet. It might have been 10 feet. But we had a picture up on the board like this. Now, thinking about our geometry that we've learned, are A and C and B and C 6 feet apart? If you answered no, you are correct. Now, what's the shape that's formed? Well, it's a square. What do we know about squares? Well, about a square, we know that the two sides are equal to each other, or the legs are equal to each other. Well, that's a special right triangle. That'd be one way to think about it. In fact, it's an isosceles special right triangle. Therefore, if we remember, this is x and this is x. The hypotenuse is x times root 2. So I could say 6 equals x times root 2 and divide both sides by root 2. And x is equal to 6 divided by the square root of 2. Now, that doesn't do us any good. It would probably help if I got my calculator out and said 6 divided by the square root of 2 and said that that's approximately 4.24 feet. Are person A and C and person B and C maintaining the social distancing guidelines? Very clearly we can see that they're not. Now, another way to think about this, we'll see if you guys remember this one, is to think about this as the Pythagorean theorem. We know that these two things are the same, right? So since those two things are the same, we could say x squared plus x squared is equal to 6 squared. Ah, Pythagorean theorem, that's right, PK. Leg squared plus leg squared equals hypotenuse squared. So that means 2x squared is equal to 36, divide by 2. X squared is equal to 18. Take the square root of both sides, and x is equal to square root of 18, which is approximately 4.24 feet. So one more way to solve it. What would be a better shape to use as a picture to indicate how far away people need to stay from each other? Yes, you're right. A circle would probably be better because we would put the person in the middle and we would say that you need to stay at a radius of 6 feet outside my circle of safety. So hopefully that answers that question about that one. But I thought this was a really interesting question because it is relevant to, what we're doing right now with this whole distance learning and social distancing, but also this idea of, being safe, but looking at it from a mathematical perspective and people that maybe don't know math who are actually endangering these two people because they're not 6 feet apart if you're staying 6 feet apart on the diagonals. So, all right, so back up to our agenda. We're going to talk about stats review. We're going to talk about one variable data. One variable data is data that just involves one variable. So maybe I get the heights of a whole bunch of different people, or I get the shoe sizes of a whole bunch of different people, or I get the ages of a whole bunch of different people. And I'm going to look at data analysis just on this one variable. So, measures of center. There are 3 that we talk about. Mean, median, and mode. Now, hopefully this is all review, but mean means, or x bar, means that we take all of our data values, x1, x2, all the way up through x sub n. We add them all together, and we divide by n the total number of data values. So this means this is your basic average. Okay, median means you list the data in order from small to big, and you find literally the middle number. Now, let's say the middle number is between 11 and 12. Let's just say we've got data that's looks like this. Now, smallest is 8, biggest is 13, middle would be right here. So we need to be halfway in between 11 and 12. So that means I would take 11 plus 12 and divide it by 2, and I would say the middle would be 11.5. That would be your median. Now, if there is a number in between there, you just circle that middle number. Mode. Mode is your most repeated data value. Okay, so hopefully these are review measures of center. Now, let's get a little more in depth about the mean. Mean means we add them all up and divide. So back in the day, there was a baseball player. His name was A-Rod. Let's see if anybody remembers him. But A-Rod signed in Seattle. This was actually before he played for the Yankees and before he retired and before he got engaged to J-Lo and all of those things. But A-Rod used to play in Seattle. When baseball players were being paid, A-Rod got an exorbitant amount of money. But most of the baseball players that get paid don't get that exorbitant amount of money. They get what's like a base salary. That's the same with football players. Not everybody gets paid Peyton Manning money. Most of the time people get paid this base salary. So when we start talking about mean, because we're adding up all of our data values and dividing by the total number of data values, very small or large values can skew. Skew meaning pull, mess up your data, okay? Can skew your mean. It can pull it very high or it could pull very low. Whereas a median literally says that here's 50% of my data and here's 50% of my data. It is literally the middle number. Median is not affected by outliers. Mean is affected by outliers, very small and very large values. So outliers are extreme data values, very big or very small. Okay, so that's measures of center. Let's get into measures of spread. So the one that you guys have used a lot in the past is range. And again, remember, range is just your largest value minus your smallest value. Okay, so range is just your largest minus your smallest. Now, I'm going to review this idea of a box and whisker plot. Box and whisker plots you get by arranging your data in order from small to large. Okay? Then you're looking for the median, which is the middle. And then you look for two other values, Q1 and Q3. Q1 is the middle of the bottom 50%. Q3 is the middle of the top 50%. So box and whisker plots look like this. Where this is your minimum, this is your Q1, this is your median, Q3, and your max. Okay? So you find Q1 and Q3 just like you find the median. You literally look for the middle of the bottom 50% versus the middle of the top 50%. So measures of spread. Graphical data. So what we're going to look at is we're going to look at histograms. And so in a histogram, you want to come up with a class size. So you want to figure out how you want to group your data. Okay, so class size is grouping data. And you will also look at a box and whisker plot. Because again, we're only using single variable data. So we're just looking at data of one variable. We're not looking at two variable data saying height and shoe size. That would be two variable data. So like the taller you are, the bigger your feet would be a concept that you might see. Okay? So the lab. I'm going to go back to those slides in a second. Here's your assignment. You're going to research a topic of your choice that provides you with at least 25 data values. These should be one variable data values. So like, I don't know, the height of something, or the length of something, or the amount of money of something to that effect. It's going to be based on one variable, but it's something that I want you to have an interest in. So you're going to do the single variable data lab that's posted in the Schoology folder. It's on a Google Doc and it uses Desmos for graphing. When you open that Google Doc, I think right the second you can only comment on it or you can only view it. So you will need to make a copy. So you will have to copy into your Google folder to actually do this into your Google Drive. If you need help with this, please log into office hours at some point in time during the week. Again, official office hours are Thursday, but I'm not going to deny you ability to contact me during the other parts of the week. So, a couple of little things on Desmos. So I pulled up these screenshots so you'll have them in your video as well. In order to enter data, you enter it using a table. Your table will have an X1 and a Y1. Notice I didn't write the Y1, and that's because you're going to actually just delete the Y1. You're going to enter your data values just in your X1. Okay, so the plus sign is going to give you your table. So you're going to enter that right there, and then you're going to just deal with X1. Now, how do we graph these data values? Well, the cool thing is Desmos will actually help you graph it. If you go into Desmos, you can graph a histogram and you can graph a box plot. You're going to do that by actually looking at the keyboard, and the keyboard that you're going to look for is this distribution, and there's your histogram and your box plot. Where was your data? Your data was in X1, X1. If you called it something else, just write whatever it is there. Now, you're going to have to play with these. You're going to look at them. You're going to use count. Probably left alignment is easiest. But you're going to have to look at this idea of height and offset and play with those variables. Okay? The other cool thing is you can actually use your calculator to help you calculate your median and your mean by looking up the stats menu. And there's median, there's mean. Actually, you can also help you find your quartile. You can tell it quartile 1, quartile 2. You can look up your minimum. It can look up your maximum. Desmos will do a lot of different things with it, and I want you guys to play with it. So, our lesson this week is short. It's not very long because I want you to play with some data. I actually want you to look up some data. I want you to research a topic of your choice. And I want you to do this lab. Now, you're going to just upload this lab into the Google assignment upload, just like we have been doing. There are a couple of additional questions, like normal, but you're going to go ahead and upload those things there. Again, log on to office hours if you are having questions. Remember, my official office hours are Thursday from 1 p.m. to 3 p.m. Anyone is welcome to get on during that time. Optionally, if you don't have other courses to attend, if you have other courses to attend, go to their office hours on Tuesdays and Wednesdays. But if you really need to get a hold of me on Tuesday or Wednesday, I'll be online during those times. And then Friday, nobody has office hours, so I'm going to open up 2 additional times for you guys to ask for some help. So, hope you guys are well. I miss you. I miss your faces. Log on to office hours. Say hello. We don't even have to talk about math. You could just say hi and tell me, I don't know, what you've been doing.